Hello, everyone. We're going to just take a few seconds and let everybody log on, and then we'll get started shortly. Well, hello, everyone. Welcome to today's webinar, A Happy Pump Room Equals a Healthy Pool, brought to you by Evoqua Water Technologies. I'm your host, Heather Hartman, editor of Campus Rec Magazine, and I am so glad you all are joining us today. So in today's presentation, we'll be identifying some common mechanical related issues in your pool, which if you do so early can save valuable time, and who doesn't love saving time and reducing operational costs in the long run. So here today we have Neil Hershey. He's the Project Management and Field Service Director at Evoqua, and he's joining us today to discuss filtration and recirculation components, along with some practical maintenance tips from his very own pump room, you can see. Please note there will be time for questions at the end, so use the Q&A tab found at the bottom of your screen. And without further ado, I'm going to hand the reins over to Neil.
All right, thank you, Heather. Hello, everyone. Thanks for joining us today. We're just going to jump right in here. I know everybody's probably as zoomed out as I am, so we'll try to get through this and provide some hopefully useful information, some things that you can take away from this and apply to your facility or your operations. So one of the key things here we're going to look at is the overview of the mechanical side of a pool. So we're not going to really touch on the deck side or the actual shell or anything like that. This is kind of starting from the surge tank, working our way through the mechanical systems and then back to the return side of the pool, and just some things to look at along the way. First thing, you've got to start with a plan. So, this is something I learned early on. I was a pool operator, came into the industry about 17 years ago now, which time flies, but that's another story. And I was handed a bunch of things being new to aquatics and new to pools. I actually started at San Diego State and ran the aquaplex there for the startup of it. And during that time, you're handed a bunch of different projects. Some of them are really small. Some of them you don't necessarily need to sit down and come up with a spreadsheet and a budget and all that. But if you get in the habit of coming up with the way to itemize everything that's going into that project and put together a timeline for it, you'll find you'll probably maybe you've missed some things along the way. So getting organized, starting with a plan, that's my first key part of this, is sit down, look at what you're trying to do, whether it's a short-term project, it's one little thing, or you're looking at an annual maintenance plan or a 10-year, type of plan, and anything in between. So with the project plans, whether it's a small project or a large project in scale, create a process that works for you and your team. That's the first thing I've tried to figure that out a long time ago, is trying to adapt somebody else's process to you and your team. Usually it doesn't work out very well. So come up with a process that works for you, that you can stick with. You've got to be able to do it over and over again as all these projects get thrown at you from all the different directions that they come in from. So this is just kind of a basic process that you put together that you can work out with your team, that exactly how it looks, how it's going to work, and it'll evolve over time as well. But start with a basic outline and template, and then watch it grow. But start somewhere to get all that information documented in one place that you can come back and refer to, and then also show your progress. And then when you're completed, have that as a record to show, okay, a year ago, here's what we did, and here's how it went. An annual plan, for the sake of this discussion, we're really looking at the maintenance schedule from the different manufacturers for the equipment that might be at your facility. You can start to build that immediately, start gathering that information and start putting together an annual plan for your facility. And then take that a step farther, a 5-10-year plan. And what does that look like? And some of those bigger ticket items, budget wise, are going to fall in that 10-year plan. So that's kind of the breakdown, but it's a similar process. You can use the same outline for kind of all of these, and build it out depending on the size of your organization. And I know there's special softwares out there that can do that. This is just taking this very simply in a spreadsheet format, something that you can keep locally with your team, and you can manipulate it and watch it evolve as the project evolves or multiple projects start coming in. So we're not going to go into how to build that spreadsheet. There's a lot of different ways to do that, but the key part is come up with a process that you can stick with, that your team will work with, and that gets you from point A to point B in a very kind of organized fashion as possible. And that's easier said than done. So organized, that's the next thing. So you get those plans going. You might have, who knows, a dozen, 20 plans going at once, all these different projects happening, big things, little things. It's very easy to become overwhelmed depending on the size of your organization, the manpower that you have available, the time, the money, all that stuff. It's overwhelming. Build a very simple file structure to keep track of that. Especially now, everything being cloud-based. If you come up with an easy way that you stick to, that everything is organized and in place, it makes it that much easier to come back to down the line. And you can go right to the job folders. I still have folders from 10 plus years ago that I refer back to. And how did I do that back then? Okay, let me pull that up. And staying organized, it's really proven to be beneficial. Not just from an operations standpoint, just in general when you're trying to budget for something or trying to put a project proposal together, things like that. Having all the files organized and up to date and in a place that you can grab is very key, and it takes some time. It's kind of that garbage in, garbage out situation. So stay organized, make sure it's useful information, go through and maybe build an archive in there as well. So all the old stuff that's not going to be applicable can go in an archive, but very simple. Build a little way to stay organized within your electronic files here. Keeping good records. So this all starts kind of coming together here. So you've got your plan, you've got a way to keep all of your information organized, and then keeping records. And this is something I started doing many years ago, and I've recommended to a lot of people over the years of how to easily keep track of this information. So in this particular example here, we're using a form. There's several platforms that are free, that are very low budget, but you can go in and create a customized form that you can pull up from smartphone, tablet, computer, anywhere, and build whatever you'd like. So for this particular case, we're looking at a mechanical room for a pool. So a daily checklist might be, you're looking at your flow rate, some basic water chemistry parameters, filter pressures, the list can go on and on. The point is you can create a form right there. You can pull it up on your phone once a day, multiple times a day, whatever you need for your facility. Put that info in, hit send, populates a spreadsheet. So here it goes back to that organization. You can have a folder, you're living there, the spreadsheet lives in that folder, it gets populated. Depending on what platform you use, you may need to copy and paste or something, but I think you get the idea. So as you build that up, the idea is you're gathering that information, and there is very expensive options out there for softwares that help you do this sort of thing. This is just a very basic, bare bones way to do it that you could start tomorrow. It doesn't cost anything, and you could start gathering that information. So you start to have a historical outlook of what's happening at your facility, in particular in your mechanical space. So all that's ready to go. You've got your plan, you're organized, you're gathering data, and now what are we gathering? What are we looking at here? In this particular case, it's very important to get familiar with your mechanical systems. So there's going to be a lot, we're going to go through here shortly, but the basic overview is just become very familiar with and learn your mechanical systems. It's going to take some time. Dedicate some time to that, whether you're brand new or to the industry, or you've been around for a long time, but you have maybe some new equipment coming in. Can't stress that enough. Be sure that you take the time to really dive in and learn that equipment as best you can, and then apply that. So starting with the surge tank, we kind of had a brief overview picture there. And in this case, the surge tank, there's a lot of variations. This is kind of where everything comes in from the pool, generally in a larger pool, into a surge tank. It's kind of acts as a balance tank. This is really kind of a forgotten area in a lot of cases. It's kind of that first spot where water and debris come into your mechanical system. So it's very important to take a look at that regularly, inspect it, make sure that there's nothing odd going on. It's kind of your first indicator that maybe you have something going on in your pool. If you notice that there's unusual debris building up, maybe in one surge tank, but not another, odd things do collect there. So I use that as kind of a first glance at the overall health of your system. They do require periodic maintenance. If you get in there and clean them out, generally annually is adequate, but that is important to make sure that's on your list of things to be checking and looking at. And there's a couple things that go along with that. So I've made a note there. Could be considered confined space. So this goes back to having that plan. You may not be able to just jump down there and pull something out of the surge tank. You may need to have a procedure to access that space, have multiple people, have all the safety precautions in place before you go into the surge tank or that space to do the necessary maintenance. So if you have a plan for that and everybody's aware of the plan and on board with it, and it may be something you just repeat periodically, but you have it ready to go, everybody's familiar with it. We need to go in the surge tank. Here's what we're going to do: 1, 2, 3, 4, and off you go. Helps you not miss any steps and keep it as safe as possible as well, while you're taking care of that critical maintenance piece that may be needed in the surge tank space. So after the surge tank, right on the other side of the wall is generally a pump pit where all your pumps and strainers and everything comes through from the concrete wall and hits that pump, and then it's the start of your circulation system inside the enclosed mechanical space. Generally the pump pit is down below grade. Generally, most pumps require flooded suction, so they're going to be kind of the lowest point in your mechanical system. A strainer will be on the suction side of the pump to provide a layer of protection. So any debris that's come through your surge tank is going to get caught in that strainer, and then protect the pump and everything downstream. The pump pit's also pretty loud, so it's one of the things too. If you're doing daily checks and things like that, it's not a space you're going to want to hang out in. So if you have a quick way to go down and take pressure readings, look at whatever things or other things might be down there, get in, get out, and gather that data, log it, and continue on with your day. So strainers are important to check. I recommend checking them daily. You never know, especially in an outdoor facility, what's going to come through your system, and if you're not keeping track of that, it's going to have a major impact on your circulation system. So if that strainer basket gets clogged up, the overall flow rate's going to drop. Your pump's going to potentially start to have some issues, especially if it's an ongoing thing. It's a pretty simple maintenance item. However, there again, you still need to have that plan in place. What are we trying to achieve here? Is it just looking at it? No, we need to address it if needed. So if we're checking the pressures and the vacuum on the suction side of the pump, that's a key indicator that basket may be clogged. And in the photo here, of course, we have 3 photos here. There's 3 different types of strainers. They all look a little bit different. So one you can visually inspect with a light, right in the top and see no problem. Yeah, it's clean and clear, or it's dirty. Other types are solid. They have a metal lid or a solid lid that you can't see through. So you're really relying on those gauges, or you just have to open it up and take a look. So, there's a lot of ways to go about this, but it's a key part, that first line of defense for your circulation system. Anything coming in, it's going to be captured right there. You can easily pull and clean it, but it's a key thing to check daily. As you get to know your systems, of course, you may know that some pumps, a feature pump or something, doesn't necessarily need to be checked daily, but the main circulation pumps, I fully recommend checking those daily, just to make sure you don't have any surprises. So while you're there, cleaning your strainer basket, the pump is right there connected to it, generally really, relatively close to the strainer. I recommend taking a look at it. This comes back to getting to know your mechanical room. Do things sound the same? Do the vibrations feel the same when you're down in a pump pit? Generally you can kind of tell if something's off. There's some indications there of upcoming potential maintenance issues, and also visual inspection. The photo here is showing a slow leak at a mechanical seal on a pump, and you might be able to run like that for some time, but the longer that you have a potential issue like that, let it go. The longer you let it go, the harder it's going to be to repair, and the more expensive generally. Especially if you're going to hire something like that out. If it takes more time, all that adds up, and it's something that could be prevented ahead of time. But there again, you've got to be paying attention. Got to be down there, doing those daily checks, looking at all these things, visual inspections, and just noticing things. Be aware when you're in a mechanical space. there's a lot of variations in pumps too. So we're not going to go too deep into any of these subjects. It's just an overview, and your different facilities are going to vary. So get familiar with what you have on site. You may have several different types of pumps on site. It's just important to keep track of that. I'm going to just go back a couple here, and this is there again, kind of having an overview here and being able to identify these different pieces. Some mechanical rooms have a lot of different feature pumps and things like that that have different operational time schedules that are going to require different amounts of maintenance. So this all kind of comes back to that planning portion of really getting to know your mechanical systems and not necessarily having to do all the maintenance on everything all at once if you're planning ahead accordingly. So moving on from the strainers and the pumps, the water, of course, heads up usually into an upper mechanical room area. Sometimes it's on a similar level, depends. There's a lot of variations out there. The next thing that water is going to hit after it goes through the pump is generally a filter. And from the filter, you've got a lot of valves that come into play. You might have some other components like UV systems. Of course, there's heat. Then we'll get into some of those other systems here as we move through this. So filter systems, there's a lot of different filters out there. They all require routine maintenance. A lot of it, most filter systems, it's all based on filter pressure readings. As that filter gathers dirt and debris, those filter pressures are going to change. And that's kind of your key indicator that there may be some sort of maintenance needed, whether it's a routine maintenance, backwashing a sand filter, regenerating a regenerative media filter, or changing media. There's a lot of variations there. And the key part is they all require some level of routine maintenance. And so coming back to the planning piece, build that into your plan. What's it going to take time-wise? Is there any expense associated with that? And kind of keep track of that as you build your plan. All the manufacturers of any of the equipment that you have, they do have recommendations. So if you're not sure what they are, get in touch with the suppliers of your equipment, find out what they are. If you have any doubt, that information is generally available, and you should be able to build that into a preventative maintenance plan and kind of have a feel for the routine maintenance. Each system is also going to operate a little bit differently based on the bather load. So went back to that, going back to that, tracking of your mechanical room, to keeping records. You're going to see that different systems probably have different, kind of loading and different time frames for all this different maintenance. So that's important to build into your plan as well, and realize that it's not necessarily, everything's not going to move at the same pace. So, tracking things like your flow rate, pump speeds, all of that kind of comes back together to basically give you an idea of timing and make sure all your equipment's running at peak performance based on, the loading in that particular pool. This is just kind of an overview. I like to take, some of these diagrams, and you can kind of build your own mechanical room in a sense. If you pull this together, and you can kind of label, a lot of mechanical rooms, if depending on how they were built or when, there's going to be, valve tags and things like that. And you can go through and get a real good idea of where all the valves are, what should they be doing. And if you have an automatic system or semi-automatic or whatever it is, keep records of that so you know what things should be doing. And then in the case that if something comes up where it's not doing that, then you have a pretty good idea of where to start, looking at that and troubleshooting it. This is just a quick overview of regenerative media filter system. For those of you who aren't too familiar with that, it's surface area filtration. Sand is depth filtration. We're using a sand bed that uses the depth of the sand for filtration. Regenerative media is a surface area, so it's a thin layer of perlite or DE media that coats a series of tube elements and gives you a lot of surface area for filtration. Generally regenerated daily for optimal performance. Big difference is, regenerative media filters down to about 1 or 2 microns, give or take, and sands, a 20 to 30 micron range, depending on the system and the grade of sand, and there's a lot of variables there. At those finer filtration rates, they of course gather finer debris. So, if they're working right, they're going to get dirty. They're going to require periodic maintenance, and that's just something to build in a plan. Can't stress that enough. You're going to start seeing a theme here. The sooner you can get those intervals down, though, the easier, the job of at the facility there for the operator will be to know, for planning for some of this maintenance of what do those intervals look like. Is it, every 3 weeks, 4 weeks, 6 weeks, on out from there, and then you can plan accordingly. This particular setup, just to give you the overview here, this is showing instead of a mechanical bump for the regenerative media, this is actually temporarily reversing the flow of water through the top of the tank and dislodging that media. Provides about a 40% stronger impulse to get that dirt and debris off the tubes, and then it's a very temporary, like 40 seconds or so, flips the valves back around and goes back into filter mode. So we could probably spend 2 days just going through this type of system, but for those of you who haven't seen that piping configuration, just wanted to point that out. On down the line past the filter system, generally there could be a UV system in line, generally in a bypass loop. It's important that the full flow of water is going through that bypass loop, and that all the water is going to be treated by the UV system that's going through it. It's important to note too that only the water at that UV chamber is getting treated. So there's no residual with UV or anything like that. It's a full flow through design, and all the water going past that chamber is going to be treated by the UV light. Those also require preventative maintenance. Every UV system that's out there is going to have some sort of maintenance interval, whether it be for the lamps or the quartz sleeves. There's a lot of different variations, but generally they all require some level of maintenance, and 6 to 12 month intervals, depending on the style, the usage, the bather load. All of those things come into play. So it's just important to keep track of how that's going in your facility so you can plan ahead. So pointing this out, kind of the basic overview here. I'll just skip back and forth, but in this loop here, you've got the UV chamber, and this is basically what it looks like outside of a schematic. So you generally have a chamber, the lamps and sleeves inside the chamber, and the basic preventative maintenance is to remove the lamps, remove the quartz, clean everything, replace the lamps depending on their age and what the output is, and put everything back together. So just kind of included this for those who maybe haven't seen the inside of a UV system at this point, but pretty cool. Pretty basic, but it also does require that routine preventative maintenance to work at peak performance. So anodes, this is something that you might find in a UV system attached to a UV chamber. You can see there what a new anode looks like and what a depleted anode might look like. So in general, this is a good way to look at the overall health of your circulation system. Potentially, if you have any corrosion going on, you're going to see it right away in the anode. Generally, anodes last 6 to 12 months, possibly longer, depending on your water chemistry and the conditions on site. So if you're if you're going through an anode regularly, it's an indicator you may have something else going on that's corrosion related. So take note of that. Good key overview of what the status is of your overall system. So back to that planning part, a small leak will gradually always get worse, and it's going to cost a lot more to repair and replace later on down the line. Have a qualified person do this. It may seem like a basic repair, but usually those type of repairs, they end up being a lot more difficult than they appear. In this case, in the example, there's just a cracked flange. Should be really straightforward to replace. However, you can see here, it wasn't quite the case. It's a little bit more involved to cut those bolts out and get everything back up and running, where if it had been done early on, the bolts probably would have come out easily, and it would have just been a matter of replacing that flange. Instead, had to grind everything out and then replace a lot more components. So tracing the lines, this is something I'd highly recommend if you have this available for your facility, is to get a schematic like this, print one out, make notes on it. You can get them printed quite large if you'd like, if you don't already have it, or electronically make some notes on there so that you can have an overview of your systems and identify where everything is at in your mechanical system. So tracing down the line here, we're coming in, we've got the strainer and the pump coming in. This is just a line diagram basically showing the flow of water through the system, identifying the major key components. So every system's going to have should have a strainer and a pump. There's going to be valves indicated in there. If you follow that through, you're going to see your filter system. Just kind of tracing through, we've got the UV system that we just looked at, the bypass loop. All this stuff is identified. We've got a heat loop here, and we have a chemical injection loop. So just having this overview back to that planning piece is just really helpful. So you can have each body of water with its own schematic showing that line through, and you can use that to make notes, come up with a maintenance schedule visually so you don't miss any of the components. Everything that you have should be on that schematic, and if not, you could probably get one created that, or draw one out if needed, and come up with something similar. So water chemistry controllers, the maintenance requirements vary. There again, it does vary by body of water, by type of system that you have, by the use, the chemicals, everything that you're using. Excuse me. So a couple of key things there. Be careful not to over calibrate. A lot of times if you have changing water chemistry parameters, it might be tempting to go in there and change your calibration frequently. Please don't do that. Do yourself a favor, right? Don't over calibrate. Cycle out old test reagents. That's another big one. Make sure that your test reagents are accurate and providing good water test results. And then use that, make sure double check everything, use those numbers to calibrate too. Really maintaining the overall water chemistry balance. It really does help all of these systems last longer and function the way that they're designed. So that comes to play for all the different components, in the mechanical room. In this case, a chemical controller is generally two parts. You've got the electronic side that shouldn't really require any maintenance, but it's that flow cell side, the wet side, that's going to require that routine maintenance, cleaning the probes, periodic calibration, just a visual inspection to see what's going on with your water. That's usually a key, visual indicator there. If you have anything odd happening, it'll start to show up in generally in a chemical controller. There's also generally a strainer in place. If you have anything getting caught in that strainer, that's an indicator that maybe you have an issue upstream that is moving down to that spot. So there again, build that into your plan. Routine maintenance for the controller will make sure it's operating as it should for the life of the equipment, and be a lot more user friendly on site as well. So locating your heat loop, there's a couple different styles out there. There's direct fired heaters, there's heat exchangers. Identifying where that is, how it's controlled, what it's tied to. A lot of times it's kind of a forgotten piece. As long as it's working, nobody really pays much attention to that part, but it's as soon as it's not working, you hear about it from everybody that the water's cold, or there's a lot of different applications here. So that's a key part, right? If the water temperature is not perfect, you're probably going to start hearing about it at some point, and then trying to track all this stuff down when you need it back up and running just takes a lot more time, and it's generally going to cost considerable more if you wait for something like that to go down versus servicing it ahead of time and identifying where it is in your loop, building that into your plan, and having that key piece of the puzzle accounted for. One of the things is a visual inspection. So, on a direct fired heater, you're going to start to see a buildup of soot potentially in the heat exchanger fins. Most heaters have a little viewing port you can look in. If you see a bunch of stuff glowing in there, probably needs to be cleaned. That's something that should be done preventatively to clean that out. The air going into a heater directly affects this sooting. So, if you're outdoors, if there's a lot of dust, if there's if there is no filter on the front end of the heater, for example, that could be an issue. Just a lot of things to look at when you're identifying these components, and make sure that work with your service providers, work with the manufacturers, make sure that everything is set up the way it should. But if you start to see things, back to your record keeping, if things start to change, get a visual on that piece of equipment, see what's going on, get to know what should it look like, what's it supposed to be doing, and what is it doing. Heat exchangers are generally a lot more forgiving than a direct fired heater. So there again, though, there is a whole nother level of maintenance for a heat loop that provides water, those heat exchangers, or liquid for those. So all these pieces of equipment have some layer of maintenance required to keep them running as they're supposed to. So chemical injection points, this is another one. Identifying where are those. Sometimes they're not as easy to spot as you might suspect. There's a lot of different variations of injectors and types of chemicals, all those things. There's, we're not going to get too deep into each particular one here, but the idea is just identify where they are, whether in this case there's a separate loop for those injectors, whether you have that or if they're just direct injecting into the main piping, or if they have a loop where they're isolated. All these things may affect how you're going to be able to service them. So in this case, with a loop, you could isolate that loop and then you could service your injectors without shutting the whole filtration system down. In other cases, you may have to turn the entire system off to be able to access those injectors and service them. Here's a little visual of that. Different injectors are going to have different lifespans, and sometimes they may actually be gone. It's hard to know until you get in there and know what each body of water is doing and what the interval is that your facility. And in this case here, they're direct tapped into the piping. So to replace this injector, you'd have to shut the system down and do that service, which could interrupt your schedule and your program and everything else. So it's better to be proactive on these type of items and make sure that you're planning ahead. It's built in. You've got it into your routine plan, and it's not a surprise on a Friday before a big swim meet. So bringing it all together, that's a lot of information, relatively short presentation for the amount of information we just went through, meant to be an overview for you just to kind of build that process to take back to your facility. Using schematics to visually identify your systems and get familiar is really helpful. I've found that to really speed that process up, and then you have a record of it too, so you can go back to that 6 months down the road. Maybe you haven't looked at it, and you can pull up your schematic and go, oh yeah, trace the lines, this is what I'm looking for, this is where it is, and be able to quickly identify what your potential issue may be. Keeping those records up to date, sharing them, looking at them regularly will help you identify a trend. Maybe you have the best preventative maintenance plan set up, it's dialed in, but if you're not looking at the data that you're collecting, things happen in between those intervals. There's always a surprise. Every pool is different. Every facility has different challenges. And so having that basic setup of records and things to look back on, the trending, there's a lot of different ways to do that, but looking at that regularly, identifying it ahead of time will save you a lot of potential emergency repair costs and unexpected closures down the line if you're able to identify things early and be proactive to correct them. Making those repairs, if you can plan, if you have that plan in place and you have the procedures and your team's all on board, scheduling service, making repairs becomes a lot easier. You're not scrambling to relocate programs and come up with other ways to do things at your facility just because maybe a pool has to be down for a certain amount of time. Be able to plan ahead, be proactive, do that ahead of time. Everybody is a lot happier around your facility at that point. Saves a lot of time. I think time is probably the big one, these days. Of you can't afford to be down. You've got to be operational. You've got to the expectation is that facility is going to be open. Those programs are going to happen, and to have something like a small blockage in a pipe, as this photo shows, shut down a program, that's difficult for the entire facility, and especially the staff trying to figure that part out. This particular example here, this is a pipe blockage over time that was growing, and the only way it was kind of identified was keeping track of all the different pressures and everything. It wasn't really adding up why the flow rate kept just diminishing. Looked at the pump, the pressures, everything else was good, but that flow rate just kept kind of dropping down over time to where it had to be, something in the pipe. And sure enough, ended up kind of tracing through and taking a look at what's the most probable spot and cutting into the pipe and finding a blockage. So you never know. It's not something that you'd you can really plan for. It's not necessarily a preventative maintenance item that a piece of equipment you need to do every 6 months or something, but having that data to look back on and say, okay, this has changed significantly. There's got to be something going on. Where do we start? And that helps tracing back through your piping and being able to identify narrow this down to where one pipe cut and it was found. So thank you for your time today. I did want to point out that all the schematics, let's go back to this one, were provided for us for this session from Water Technology Inc. So thank you very much for helping put those together, and really nice way to look at a mechanical room. So I just want to make sure to thank them for contributing to that. And I'm Neil Hershey. So, my email here is here, and we'll move on, I guess, here, Heather, if we have any questions, and yeah, go to that.
Awesome, Neil. Thank you so much for that presentation. I really appreciate that. And I do have some questions for you. And to our attendees, please submit any questions you have in the Q&A button that you can find hopefully at the bottom of your screen. Neil, first question I have, where is the best place to start? Let's say I'm new to managing a mechanical room and need help. What would you say is the best place to start?
Yeah, there's a couple ways to go about that. One would be find another operator. Like if you're brand new to operating a mechanical room, get to know somebody that's done this for a while and potentially get a tour of another facility, see how they do it. Bring in potentially your vendors, service providers, and have them help line you out on this. So have your schematic and work through one at a time from start to finish, kind of how we just did in the mechanical space, to start building that checklist for your, whether it's your preventative maintenance, or maybe you have something that you need to replace or a project coming up, but kind of using the networking resources that you might have and start with that. There's no need to recreate the wheel, I guess. Try to reach out, ask other operators what they've done and what works for them, and then try to build your own system that works for you at your facility.
No, that's good advice. It's always helpful to reach out to others who can possibly help. So that's great, Neil. Another question for you. Should I budget for new equipment years in advance, or wait for things to break and use my repair budget?
Yeah, it's a tricky one. Generally, knowing the lifespan of equipment or the expected lifespan, start budgeting for it as soon as you can. In my opinion, you're always going to have stuff breaking. It seems anything with water, it tends to break sooner than you would like. So you're going to have to deal with those items as they come up. But if you're constantly budgeting for equipment replacement, whether it's 10 or 20 years out, that will help. When the time comes, you've got that set aside, hopefully, to be able to make that a smooth transition to the next piece of equipment that you might need.
Awesome. Yeah. Thanks, Neil. Appreciate that. Another question. How long does a chlorine injector usually last?
Yeah, so for sodium hypochlorite, the actual length of the life may vary a little bit depending on the chemistry and the type of product used. I recommend basically checking them at least monthly, and you'll get an idea of the wear and tear on them. If they're checked monthly, you may get a year out of them. Be a good thing to have on hand, to have spare injectors on hand. Some of those items are inexpensive. They're easy to swap out if you have them. If you don't have them, then you're potentially looking at having to come up with a fix in the field or scrambling to get them in the last minute. So that's a great question. Good to have on hand. The mileage may vary a little bit. Depends on the amount of product being used. It depends on your water chemistry. If you have really hard water conditions, they're going to scale up faster than softer water conditions.
Yeah, no, makes sense. And I have another question that kind of goes off of that, actually. Are there any items that you'd recommend, in particular, that I should stock on site?
Yeah, great question. I would, back to your plan, if you're working through the mechanical system, reaching out to the manufacturers of those pieces of equipment, ask them what you should have on hand, whether that's injectors or, filter cleanse products, spare probes for your water chemistry controller, those type of items. Relatively inexpensive, generally have a long shelf life. That's something to bear in mind. If you do get new probes, you don't want them sitting around for 3 or 4 years before you use them. But certain items, it's really good to have at least one set of on site at all times. So that way you can swap them out if you need to.
Awesome, Neil. Well, great. Those are all the questions I got for you. So thank you so much, Neil, for the presentation and for all the education. Thank you to our audience members for listening in, tuning in today, taking time out of your day to, just go through this discussion and get some good maintenance tips for your pump room to hopefully make it happy. So thank you to Evoqua Water Technologies and Campus Rec Magazine as well. And Neil, we're delighted to have you today.
Thanks so much, Heather. Really appreciate it. And if anybody has any additional questions about any of this, any maintenance, setting up a program, please contact us. Happy to chat anytime. Really, thank you.
Awesome. Great, everyone. And in case you want to watch this again or share it with a colleague, this will be on demand on campusrecmag.com shortly. So, all right, Neil, thank you so much. And thank you to everyone else. All right, bye-bye.
Have a great day.